Welcome to this threat modeling presentation. This presentation is for engineers, developers, architects, or a business person. Let's get started. Threat modeling identifies, communicates, and builds understanding about threats and mitigations within the context of protecting of something of value. We have to structure our threat model to represent all of the information that affects the security in our application. Essentially, it is a view of the application and the environment of the lens through security. Threat modeling is applicable to a wide range of things: software, applications, systems, networks, distributed systems, the Internet of Things, devices, and even your business process. Threat modeling has to include a description of what it's going to be modeled, assumptions that can be checked or challenged in the future, potential threats to the systems, actions you can take to mitigate each threat, and a way of validating the model, threats, and a verification that the actions you took have been successful. We need to assume a couple things when we are working on our threats, right? Threat modeling is best applied through the life cycle of a software development project. The process is essentially the same at the different levels of abstraction, but the information gets more and more granular during the life cycle. A high-level threat model should be defined early on in the conceptual and planning phase, and continue to refine your threat model throughout the life cycle of your software or project development. As more of the details are added to your system, we introduce new attack vectors, and we need to create and understand how those attack vectors are exposed. That ongoing threat modeling process should let your team examine, diagnose, and address those threats. Here's some times that you should update your threat model on the screen. We're going to examine the 4-question framework to really make just total sense of what we're going to do. Our threat models should combine the likelihood of a threat occurring and the impact that could have on the organization that would create a significant risk to operations, people, processes, machines, right? So let's dive into it. What are we working on? Let's assess the scope. Where's our focus? And is that a sprint or is it an entire system? What can go wrong? Let's identify the threats. Use something like Stride, a kill chain, or attack trees to really brainstorm potential issues. And what are we going to do about it? How do we manage the risk? How do we decide on a countermeasure for our team and risk management approaches to either accept that risk, transfer it, or eliminate it with a system or configuration or process change? And did we do a good job? This is where those metrics come in. Key performance indicators that evaluate the effectiveness of that mitigation. There should be a system change, there should be a control, and you can prove that beyond a doubt by examining and forensic analysis. We want to provide a clear line of sight across our project, justifying our security efforts. We also have to make sure the user experience of security isn't off-putting. Designing a system that's inaccessible will create users that will bypass your security controls. So make sure they work, make sure that all of your users can use them, and make sure that they're clear and you have good auditing on them. Create an assurance argument to explain and defend the security of your application. So what are the benefits here? Informed security decisions let your team really just understand why they're doing something, right? And it provides us some assurance about the arguments we're starting with and justifying those high-level claims with a subclaim and evidence that we followed through. Here's some examples, right? We need to have our application name, version, a description of it, who's the document owner, who are the participants in that modeling process, and who's going to review that the work was done successfully. Additionally, here's some examples about Stride that you should consider. And I'm going to give one example for each of these concepts and the security control that you need to consider. In spoofing, this threat is aimed at accessing another user's identity or credentials, like a username or password. The security control we're considering here is authentication. And before we authenticate, we need to do good identification. Tampering is maliciously changing or modifying persistent data, like records in a database, or the alteration of data that's being in transit. This is about integrity. That's the security control we're looking at with tampering. Repudiation is aimed at performing prohibited operations in a systems. So what we're focusing on here is non-repudiation. That's the security control. Information disclosure, that's a threat action intended to read a file that somebody isn't granted access to. So we're focused on confidentiality here. Denial of service, that's the threat actor attempting to deny access to valid users by making a service unavailable or unusable. We're focused on availability in this domain. Elevation of privilege, This threat action is trying to gain privileged access to a resource or system, to gain unauthorized information, or to compromise your system. The security control here is authorization. Considerations for exploitation assessment, right? Here's what we need to understand about how something is exploitable. Can the attacker do this remotely? Does the attacker need to be authenticated to make this exploit occur? And can the exploit be automated? Additionally, let's talk about how to assess the impact of something. Can the system be taken over completely and an attacker manipulate the system? Can they gain administrative access? Can they crash the system? And can they extract sensitive information that you want to protect from your clients or customers? We need to understand the extent of a threat. How many data sources and systems can be impacted? And how many layers of your infrastructure and components can the threat agent traverse? Remember that the impact and extent considerations are really vital in understanding the scope and severity of potential threats. I hope you found this useful. We'll see you again.